Hi and welcome. In this video, we'll see how we can calculate quantiles and percentiles. Consider a quantitative variable x, and suppose we have collected data on this variable from a population of interest. And this is the data that's being collected on this quantitative variable. When it comes to quantiles, there are three quantiles used to specify three important locations in the distribution of the variable x. Quantile 1 is a number which is larger than 25% of all observations. Quantile 2 is a number which is larger than 50% of all observations, and quantile 3 is the number which is larger than 75% of all observations. Note that Q2 is the same as median, that is, Q2 is exactly the midpoint of all observations. To find the three Qs, first of all, we sort the data being collected on the variable x. In other words, these observations from the smallest to largest. In order to find the location of Q1, Q2, and Q3, we use these formulas. For Q1, 0.25 times n plus 1. For Q2, 0.5 times n1 plus n. For Q3, 0.75 times 1 plus n being the number of observations. As you can see here, we have 25%, 50%, and 75% corresponding to Q1, Q2, and Q3. Then we check to which values these numbers correspond. Let's consider the example of age of all 9 employees of the company and find the three Qs. First, obviously, we sort the data being collected on the age from the smallest to largest in this last column. For Q1, we multiply 0.25, which is 25%, with 1 plus n. N is 9. 1 plus n is 1 plus 9 is 10 times 0.25 is 2.25. And then you round off this 2.25 to the nearest integer number, which is 2. That means the location of quantile 1 is 2, which corresponds to this observation 23. Therefore, quantile 1 is 23. For Q2, of course, we multiply 0.5 with 1 plus n, which is 5. Therefore, 5 is the location of the second quantile, which corresponds to this observation. Hence, Q2 is 28. For the third quantile, we multiply 0.75 with 1 plus n, which becomes 7.5. Now, 7.5, we cannot round it off to 7, neither to 8, because this is in between, exactly in the middle of 7 and 8. As we know, 7 is corresponding to 33 and 8 is corresponding to 35. Therefore, we need to find the midpoint of 33 and 35, which is 33 plus 35 divided by 2, giving us the midpoint of these two observations, which is 34. Therefore, Q3, which is the third quantile, is 34. We can show Q1, Q2, and Q3 on the graph, on the distribution as well. Q1 is a number down here, which is larger than 25% of observations. Q2 is 28. It's the location of Q2 or quantile 2, which is larger than 50% of observations. Of course, it's smaller than the rest 50% on the right. Q3 is 34 somewhere here, which is larger than 75% of observations, and of course less than 25% of observation on the right hand side. In addition to those three quantiles, we can find any other percent, let's write P, that we want. The P percentile is a number which is larger than P% of observations. To find the P percentile, first of all, of course, we sort the data, then we find the location of the P percentile by multiplying P% with 1 plus n, n being the number of observations, then check to which observation this number corresponds. Again, let's go back to the example of the age and let's find the 60th percentile of the age. That is the number which is larger than 60% of total observations. Again, we consider this sorted column here. Then find the location of 68th percentile by multiplying 0.6, which is 60%, with 1 plus n, which is 6. Therefore, the location of 68th percentile is 6, which corresponds to this observation here, 30. Therefore, the 68th percentile is 30. That means 60% of observations in our data are smaller than 30. In other words, 60% of employees in the company are 30 or younger. Thanks for watching and good learning.